How are we doing, guys? We're looking at quadratic sequences in this video. We're looking at page 430 in Jackson Test 2. Just question 1, part 1 says find the first 4 terms of this sequence here. So this is a quadratic sequence. Why? Because you've got your n squared. So anytime there's something squared in it, it's going to be a quadratic. So the first term is when you plug in a 1, you get 1 squared plus 4. That's 5. The next term is when you plug in a 2, you get 2 squared plus 4. 4 plus 4 is 8. Next one, you plug in a 3 squared plus 4. 9 plus 4 is 13. And if you plug in a 4 squared plus 4, you get 16 plus 4 is 20. So this is a quadratic pattern, 5, 8, 13, 20. And the characteristic that you see there as well, if you look at the first differences, you get 3 there. From 8 to 13, you have to add 5. From 13 to 20, you have to add 7. So you don't have a fixed first difference, but you do have a fixed second difference. Okay, so this is called the second difference. And that's kind of the characteristic of a quadratic pattern. So if you're trying to find the next number along, you'd say, well, add 2 again, that's going to be a 9, isn't it? So 29 would be the 5th term. And let's just check that. T5 is 5 squared plus 4. And yeah, that makes 29. If you wanted to go backwards, well, you might be able to guess from the formula what the 0th term is going to be, or T0 is 0 squared plus 4. But if you were to work backwards, you'd be saying, well, I need to be adding a 1. So my 0th term here is 4 and then 5. And as usual, I'll put that slightly out of sequence just because we normally start, we say the first, second, third term. The 0th term is a useful concept for when we go looking for the formulae. I'll just point out that that's a 1n squared. Okay, and 1 is half of the second difference here. We're going to see that pattern come up again. Okay, we're going to skip up to question 6 here. We've got this sequence 4, 7, 12, 19, 28. And they want to say, what's the first difference? What's the second difference? And they've given you this formula, okay, which is a quadratic formula. This is just for a quadratic sequence. It would normally be x squared plus bx plus c, ax squared plus bx plus c for a quadratic function. But as we've seen before, very, very similar ideas. So let's work through that one. Right, what are my first differences? 4 to 7 makes 3. 7 to 12, I'm going to have to add 5. 12 to 19, I have to add 7. 19 to 28, I have to add 9. That's my first difference. My second difference then is going to be plus 2, plus 2, plus 2. Okay, and as I said earlier, if you want to write them out in this form, okay, an squared plus bn plus c, where this is the general term. Well, that a, just like it was up here, that's always going to be half of this second difference. So that's quite useful because we can now fill in what half of that is. And that c is always going to be the 0th term. Okay, so term 0, if I work backwards here, well, I've got 9, 7, 5, 3. It's going to be a 1. So term 0 here was a 3. Okay, so just offset that a little bit rather than having it in the sequence. So straight away, if I'm asked to find a formula to describe this pattern, well, I can say the A has to be a 1 because it's half of the second difference, and the C has to be a 3 because that's the 0th term. Okay, so our formula to describe this quadratic pattern, we know 2 of the 3 numbers that we're going to want. We don't know B, but I can come along straight away and say, well, the nth term in that quadratic pattern is going to be half the second difference here is 1n squared plus b, I don't know, times n, plus c, my 0th term, is 3. And then I come along and I pick any one I want to the first, second, third term. It doesn't matter. I'm going to work with maybe the first term. I'm going to say, well, I know that t1 equals 4. So let's plug that in. If n is 1, t of 1 is 4. So 4 equals 1 times 1 squared plus b times 1 plus 3. Okay, and this is how you find b, because you've got an equation now that only has a b in it. Okay, so you just plug in any one point or one element of your pattern of your sequence. So that says 4 equals 1 plus b plus 3. So 4 equals 4 plus b and b equals 0. So our pattern is going to be 1n squared plus 0b, or 0n, sorry, plus 3. Let's just check that we got this right. Okay, come back up to where you started. And let's say the first, second, third one. If I plug a 3 into my pattern, do I get a 12? Well, 3 squared plus 3. 3 squared is 9 plus 3 makes 12. Brilliant. If I plug a 4 in, do I get a 19? 4 squared is 16 plus 3 is 19. So yeah, so I can stand over that. I can say, yeah, that's my pattern there. Okay, we'll do one more, 7 part 2 here. Find an expression for the nth term of each of these quadratic sequences. Well, with this one here, it goes 2, 7, 14, 23. Okay, so we're trying to find an expression that looks like this. What are the values for A, B, and C? We remember that A is always half of the second difference, and C is always the 0th term. So let's see what we get. Our first differences are 5, 2 to 7, you need 5. 7 to 14, you add 7. And 14 to 23, you're going to add 9. Just realized I picked one with the second difference of 2, which I was not interested in. So let me pick a different one here. Okay, sorry about that. Part 3 is going to be a little bit more instructive, I think. From 2 to 8, you add 6. From 8 to 10, you add 8 to 18, you add 10. 18 to 32, you're going to add 14. 18 plus 14 gives 32. And from 32 to 50, you're going to add 18. So this is a quadratic sequence because, look, it's always the same number in the second difference. Okay, and in this case, that number is 4. So when we go to say, well, what's the nth term? We're going to say an squared plus bn plus c. Well, a is half of my second difference, so it's half of 4. That's going to be 2n squared. B is the one we can never work out. And then C is my 0th term, if I was to go back a term. So if I was to go back a term here, I'd be going 18, 14, 10, 6, 2. And if I took 2 away here, and I'll just offset it a little bit, but 0 would be my 0th term. Okay, you go 0 plus 2. Okay, but that's first, second, and so on. Okay, but my 0th term would be 0. So that's going to be a 0 there. Right, and then how do I find B? I pick any one I like. So 1, 2, 3. Let's pick the third one this time. T3 is 18. If I plug a 3 in for n, I'm going to get 18 out. So 18 out when I plug in 2 times 3 squared plus b times 3 plus 0, if you like. Well, that's 18 equals 2 times 9 is 18 plus 3b. Okay, which means 18 moves over, you get 0 equals 3b when you subtract 18 from both sides, and b equals 0. So actually this one's a fairly simple rule. Tn is twice n squared. And just check, does that work? Well, the first number on this list, or the first term in this sequence, is 2 times 1 squared, which is 2 times 1 is 2. Next one, 2 times 2 squared is 2 times 4, that's 8. 2 times 3 squared, 2 times 3 is 18. 2 times 4 squared, 2 times 16 is 32. And 2 times 5 squared is 2 times 25, that's 50. Okay, so we'll leave it there and I'll assign work separate to this video.